Hi everyone, in this video we want to work on transforming the basic log shapes. So the new part of this should be identifying the basic log function and knowing what its graph looks like and being able to find points on that graph. So I'm going to really emphasize that. From there we will apply transformations. The transformations are exactly what they are before. And I actually think with logs it's fairly easy to spot what's affecting x and what's affecting y, because if there's much affecting x, you'll need parentheses to show that. So you get the parentheses as part of a log function. If you're not seeing any parentheses in there, then probably everything that you see is affecting y. Okay, so here we want to start with y equals the log base 1/4 of t. So again, the really big deal here is, can you figure out what that basic function looks like? So part of this is going to be memorization. You should memorize that it has a vertical asymptote at x equals 0. You should have this basic picture in your head that if your base is between 0 and 1, if you have a little base, you're going to get the decreasing log shape. So I do have kind of a rough picture in my head, and that's something you just have to make sure that you work on. As far as getting points on this graph, you can memorize some if you want, but I really hope you don't have to. The idea would be you have a formula. We were working on the basic one, so don't try and plug in here. It'll make it harder. But find points on this basic graph. So if I want to find ordered pairs, I'm even going to make a table here. I don't do this a lot, but for the logs, people get in trouble, so I really want to show you step by step. If I want to plug something into a log base 1/4, the way to get things that are easy to take the log base 1/4 of are to use powers of 1/4. So one thing that's always a good option is plug in a 1. We would be asking ourselves, what is the log base 1/4 of 1? So what power of 1/4 gives you 1? And the answer to that question should always be 0. So this graph, as they all should, will go through 1, 0. It's also easy to take the log base 1/4 of 1/4 or 1/16, things like that. If you want to take the log base 1/4 of 1/4, you're saying what power of 1/4 gives me 1/4, and the answer is 1. Make sure you don't get backwards. Sometimes people can find these points, but they flip-flop. So we plugged in a 1/4, which means that's our t value. That's on the x-axis. We got out a 1, which means that's on the y-axis. So this should go through 1/4, 1. The other numbers that are nice besides 1/4 and 1/16 and 1/64 would be things like 4 and 16 and 64. 2s are even not bad, 1/2s and 2s, because the square root of 4 is 2, but let's just go for a 4. We don't need a ton of points, just a couple here to get us going. The log base 1/4 of 4. So what power of 1/4 gives you 4? The answer to that is -1. To flip something over, use a negative first power. So that was input 1, 2, 3, 4, output -1. Okay, so this is the basic function I'm starting with. And I actually only see one transformation. I think you'll find that most of what you have for practice, the transformations part is not terribly messy. The focus is really on, can you figure out that basic shape? And then it is important that you can spot what transformation is what. Because the -2 is in the parentheses, it's affecting my t. So if I plug in a t, I would first subtract 2, then take the log. So this is going to be horizontal shift. Since it's horizontal, it'll do the opposite of what it seems to do. So this is a shift right 2. Okay, so I want to pick up this entire graph and shift it to the right 2 units. Really important, every time you draw a log, make sure you show me where its asymptote is. So we'll follow that through transformations. It will end up at x equals 2. T equals 2, sorry. This is ty. The point 1, 0 shifted to the right 2 ends up at 3, 0. The point 4, -1 shifted to the right 2 ends up at 6, -1. Oops, make sure I label these right. That's a 3, 0. This is a 6, -1. And I also labeled the point 1/4, 1, so let's follow that. That'll end up at 2 1/4, 1. 2 1/4 is 9/4. You can write 2 1/4, but I don't tend to love mixed numbers for stuff like this. Otherwise, it's this same shape. It has a vertical asymptote, so it heads up to positive infinity, and then it's going to slowly decrease as we head to the right. Okay, so again, really focus your studying attention. Don't neglect the transformations, but I hope that those are starting to become fairly easy. Really focus your studying on, can you get this basic shape? Do you know what the rough sketch looks like? And can you find points on any of these graphs? I also want to look at a natural log. That one's always the trickiest for people. So for starters, just the notation. Remember that if we're starting with a plain old natural log of t, we should be thinking log base e. You don't want to write it that way, but that's what you should be thinking. So if my base is an e, I am, as always, going to have my vertical asymptote at x equals 0, and this will be an increasing log shape. So it'll start from negative infinity and then cross through and flatten out. To get the points on this graph, we want to plug in, again, you don't have to make this table if you don't want to, but finding the points can actually be really tricky for people. We want to plug in powers of e. So 1's always a great one. Again, if you try to take the natural log of 1, you're asking yourself what power of e will give you 1, and the answer is 0. So once again, we go through 1, 0. E is a really nice power of e. I'm going to go ahead and use that one. The natural log of e is asking what power of e gives you e, and the answer is 1. Remember, e is about 2.7, so a little less than 3. E1. And I'm just going to follow those two. You could do a 1 over e negative 1 if you'd like. That's great. You could do an e squared 2. Lots of choices. I'm just going to get a couple of points in my asymptote to try and make sure I get this about right. Transformations, I see the 4 outside the log function, so that's vertical stretch. And the negative inside the log function, that'll flip your t's, so that's a flip over the y-axis. Okay, so I'm going to flip the opposite direction, and I'm going to do vertical stretch by 4. I think I've been keeping these all separate in the video, so I'm going to go ahead and try and do 2 together. So if we follow the asymptote, if we flip across the y-axis, I'm picturing a graph headed off this direction, but the asymptote stays where it is. That's what we're flipping over. And then stretching vertically by a factor of 4, if your line is infinitely tall, making it 4 times as tall doesn't really look any different. So we're going to go ahead and put that x equals 0 vertical asymptote right where it was. The 0.10, when we, and you can do this in either order, I'm doing flip and then stretch, but you could reverse that. So when we flip across, it ends up at -10. If we then do vertical stretch by 4, because that point is on the x-axis, it will actually stay put as well. So not very exciting so far. The last one, E1, when I flip across, it should land at negative E1. Make sure I get those in the right order. So the E becomes negative. If I then do vertical stretch, it's going to be negative E4. So negative E is negative 2.7-ish. And then 4. So negative E4 should be up here. So it has this same log shape, but it's flipped across, so it's headed this way. And then I stretched it out, so it's taller. It's 4 times as tall. Let me think about this. Oh, I don't know if I want to think too hard about another point or not. Another point we could follow would be an e squared. Natural log of e squared is 2. So if we want to follow e squared 2, it would end up at negative e squared 2, which would then be negative e squared, stretched by 4, 8. E is a little less than 3, so e squared should be a little less than 9. So I'm just going to kind of estimate here, and you could, that's something you could check on your calculator while you have one handy, but otherwise just approximating is good. So just so that I don't get too crazy far off, it does flatten out. Something about like that. All right, thank you for watching.